Yesterday, the most common statement I heard students make who were struggling was, I just don't know where to start. And so whether you found ease with lesson 3 or you struggled, I want you to recognize multiple ways to achieve the same goal, which is simplifying and showing that the left side is equivalent to the right side. So this goes back, we're going to start with the first example. It goes back to an example we ended with in lesson 3. Now, I had a student come up and show me how they were able to demonstrate the left side equals the right side, but here's an alternative that I want you to write down. It is common to use conjugates. I'm going to multiply by the conjugate of the denominator, and I want to show that the left side is equal to the right side. Now, if I foiled the denominator, I'd end up with 1 plus the cosine theta minus the cosine theta minus cosine squared theta. And I can see that the two middles are additive inverses. They cancel out, and I'd be left with 1 minus cosine squared theta in the denominator. But notice, I'm going to take those three trig functions. I can manipulate the first equation. If I subtract cosine squared to the opposite side, 1 minus cosine squared is equivalent to sine squared. So let me replace this denominator with cosine squared. And I know that with sine squared. And I know that sine squared, that's equivalent to 1 minus cosine squared. I know sine squared could be written as sine times the sine. Sine on top and sine on bottom are just going to simplify, and notice the left side equals the right side. Let's look at our. Press pause, write down the second example, and then come back to the video. Right away, I recognize that in this last identity I have down, I could subtract tangent squared to the right, and I would have secant squared minus tangent squared is equal to 1. That means I can replace this portion with 1. 1 plus tangent of theta over secant of theta. And again, my goal is to simplify it, showing the left side equals the right side. I'm going to share the secant with both the left and the right sides of the addition sign, so 1 over the secant of theta plus tangent over secant of theta. 1 over secant is the same as cosine. Now I'm going to come off to the side here, and I'm going to simplify tangent of theta divided by secant. So let me do that off to the side, and I'm going to do it horizontally. I know tangent is sine over cosine. I know tangent is sine over cosine, and I want to divide that by the secant. So sine over cosine divided by secant. Now secant can be represented as 1 over cosine. When I divide fractions, I keep the first fraction in place, turn division into multiplying, and take the reciprocal of the second fraction. And we can see I'm left with simply with sine. Now I have the cosine of theta plus the sine of theta. Left side equals right side. Let's look at example number. This looks like it's going to be some work. I'm going to start by asking myself, how could I go about rewriting this? What would be to my advantage? I'm going to go and rewrite tangent as sine over cosine. And down here, I'm going to rewrite it as sine over cosine. Now on the right-hand side, I know cotangent is cosine over sine. And then I want to put the fractions in the numerator and the denominator together. So I'm going to use the butterfly method to do that. As a reminder for the butterfly method, we're going to multiply this first diagonal going from top left to bottom right. So 1 times the cosine of x is the cosine of x. Then I'm going to drop down the plus sign. 1 times the sine is the sine. And I'm going to divide that by 1 times cosine. I'm going to do the exact same thing down here. 1 times cosine is cosine, and then I'm going to drop down the subtraction sign. 1 times the sine of x is the sine of x, and I'm going to divide it by the cosine of x. On the right hand side, let's continue with the same operation. Cosine of x times 1 is cosine of x, plus 1 times the sine is the sine, and I'm going to divide it by the sine of x. In the denominator of the right hand side, I have the cosine of x plus the sine of x divided by the sine of x. Okay, I'm going to take the left-hand side, and instead of writing it vertically, I'm going to write it horizontally. So I have cosine of x plus sine of x divided by the cosine of x. And then normally I would write divided by, and I'm not going to skip a step here, I'm going to show all of my work, divided by cosine of x minus the sine of x over the cosine of x. Now when I do division, remember, as I said in the previous, I'm going to keep the first fraction in place. I'm going to turn division into multiplying, and I'm going to take the reciprocal of the second. We can see the cosines then are going to be simplified, and I'm left with the cosine of x plus the sine of x over the cosine of x minus the sine of x. That's what I have right now on the left-hand side. Let's do the same operation over here on the right-hand side. So I'm writing down the very first, the numerator, divided by the sine. Now I'm going to skip a step here. So division, I normally would write division, and then I would take this and put it in place. But remember, division turns to multiplying, and then I take the reciprocal of the second. And hold on here, I want to make sure I did not miss a sign here. I can see I missed a sign. Notice that this was subtraction. This should have been subtraction, and this should have been subtraction, and this should have been subtraction. I missed this sign down here and unintentionally made an addition. So I switched that in each of those locations. Okay, the signs are going to be simplified to 1, and now I have cosine of x plus sine of x in the numerator, and the denominator I have cosine of x minus the sine of x. The left side equals the right side. Let's go on to our next example. So how can we, following mathematical rules, manipulate the left and the right side to show the two sides are equal? In this situation, if I can, I prefer not to work with negatives. So I'm going to take this term, I'm going to move it to the left-hand side. When it moves over, it's going to be a positive cosine. So 1, I'm going to bring it over, plus the cosine theta. And I'm going to take this term, it's negative. When I move over, it becomes positive. Now, recall the very first example that we did in this video, and I said that it's going to become more and more common for us to multiply by the conjugates of the denominator. That means I'm writing down the denominator just as I see it, but I'm changing the sign. And so instead of it being 1 minus the cosine theta, it's going to be 1 plus the cosine theta. Let's go ahead and let's multiply. So on top, I have sine squared theta plus sine squared theta times cosine theta. Now in the denominator, I'm going to come off to the side and FOIL this. I multiply the fronts, and I get 1. And then I'm foiling, so then I multiply the outsides and I get a positive cosine theta. The inside is a negative cosine theta, and the last is a negative cosine squared theta. So those two middle terms cancel out, and I'm left with 1 minus cosine squared theta. Now I recognize that 1 minus cosine squared theta, I got to bring this back up. 1 subtract cosine squared theta is the same as sine squared. So let me rewrite the denominator. I'm going to come back to the numerator, sine squared theta. I have two terms separated by a plus sign. Notice that both terms have a sine squared. So let's factor out that sine squared. And I'd be left with sine squared times 1 is sine squared times cosine. Sine squared times cosine is sine squared cosine. Notice that when I distribute, I get exactly what I previously had in the numerator. The sine squareds are going to cancel, and now I have 1 plus the cosine of theta equals 1 plus the cosine of theta. Let's go on to the next example. All right, so writing down the equation and then coming back to the video when you're ready. I'm going to FOIL, multiplying the fronts to get secant of x. So front, doing the outsides, secant times cosecant. Secant of x times cosecant of x. Multiplying the insides and multiplying the last. And so I think, just looking at this, it's going to be not as apparent that I'll use any one of these, but I think I'm going to rely on my understanding of the 6 trigonometric functions, like sine is 1 over Sine is 1 over cosecant, cosecant 1 is 1 over sine, and so on. I want to show that the left side equals the right side. Let's see what we have here. What can I do? I'm looking here. That looks good. This looks good. That looks good. And that looks good. Okay, I'm going to go through and write these down. Okay, I know that I can rewrite this as 1 over the cosine, and I can write this as 1 over the sine. Now, I should go back and rewrite this as 1 over the cosine as well. Here, I know I have sine over cosine. And then, okay, tangent is sine over cosine, and cosecant is 1 over sine. So notice I have 1 over cosine, a negative 1 over cosine for this term, and I have a positive 1 over cosine for this term. So they are going to cancel out. All right, what else do I have? This is, make sure I did multiply this right, looking everything over. That looks good. That looks good. Okay, so right now I have 1 over cosine x times 1 over sine x minus sine x over cosine x. Goodness sakes, what would be an easier way to do this? So I want to come up with a common denominator. I absolutely could use the butterfly method, but I think it's even easier if this had a sine of x on the bottom. Notice how they'd be exactly the same. So I'm going to go times the sine of x times the sine of x. As long as I multiply the top and the bottom by the same quantity, it doesn't change its original value. Now I have a common denominator. So now 1 times 1 is 1 over cosine x sine x minus sine squared x over cosine x sine x. And when I have a common denominator, I can put that together. On top, 1 minus sine squared. And then I think it's going to be valuable to come back. What is 1 minus sine squared? 1 subtract sine squared. 1 subtract sine squared is cosine squared. So cosine squared is on top. Now I'm going to write cosine squared as just cosine times cosine. And here's the reason I'm going to do that. I can see that the cosines, 1 cosine on top and 1 cosine on the bottom, are going to be reduced. I'm left with cosine over sine. Cosine over sine is the same as the cotangent. All right, let's take a look at this problem. Please write it down and then come back to this video. I'm going to start by doing the butterfly method on the left-hand side. So I'm going to multiply 1 plus the cosine theta times 1 plus the cosine theta, dropping the plus sign, and then sine squared times sine squared, all divided by sine of theta times 1 plus cosine theta. Let's FOIL this out. Okay, there's 1 cosine and 2 cosine, so 2 cosine theta plus cosine squared plus sine squared all over sine of theta times 1 plus cosine. Well, I already see that I have cosine squared plus sine squared. I know cosine squared plus sine squared is 1, so I can replace this portion with 1. 1 plus 1 is 2. So I have 2 plus 2 cosine theta all over sine times 1 plus cosine equals 2 secant theta. All right, on top, I'm going to factor out, a 2. So 2 times 1 is 2. 2 times the cosine of theta is 2 cosine theta. And hopefully you can see right now how I have one group of cosine, 1 plus the cosine theta on top, and another group on the bottom of 1 plus the cosine theta. They are going to be reduced, and I'm left with 2, give myself a little more space here. I have 2 over the sine. Well, 2 over the sine is the same as 2 cosecants. That's pretty ugly. CSC. So 2 cosecants equals 2 cosecants. Very last example. This is a reminder that you are allowed to start on the left or you're allowed to start on the right. So going back to the first example of this video, it's a good reminder how we can multiply by the conjugate of the denominator. And so the conjugate of the denominator would be 1 subtract the cosecant of x. When I look at the denominator, I'm able, when you multiply the conjugates, you're able to just multiply the front and the last. And the reason for that is because the outside and the inside are additive inverses. So positive cosecant x, negative cosecant x, they're just going to cancel out. All right, so the next thing I'm going to do is I'm going to write down cotangent squared x and 1 minus the cosecant of x. Now, I recognize 1 minus, okay, let's see here. Here's the equation. In order for me to get 1 minus cosecant, I'm going to write this equation down because I think a lot of you need to see how this is going to work. So in order to achieve this, I would have to subtract the cosecant to the left-hand side and then subtract the cotangent to the right-hand side. So I can replace this with negative cotangent. Okay. All right, well, the cotangent on top and the cotangent on the bottom are going to cancel. The negative sign does not cancel. So this negative sign could go on top, on the bottom, or out front, however you want to handle it. I'm going to put it right there on top. Okay, now another way to write this, well, let's distribute this, by the way. I get negative 1 plus the cosecant, or that's the same as cosecant minus 1. So that's what I have on the right-hand side. I'm going to share the sign with both the left and the right. So I have 1 over the sine of x plus the sine of x over the sine of x. 1 over the sine of x is the cosecant, and sine over sine is 1. Now, I meant, hold on one second here. This is not working out. What did I do? Oh, I wrote it down wrong. I'm looking back in my notes. This was supposed to be subtraction in the very beginning. This was supposed to be subtraction in the very beginning. So please correct that. This was supposed to be subtraction, and now we have the left side equals the right side.